Ooh, I think we can wait for like just another minute and then we can get started.
Got a lot of folks in. It's
Yep.
it's looking good.
Yeah, everyone's excited to get started with Ethereum. So yeah. So, yeah, I think we can get started. So first of all, I'd like to welcome everyone to the first workshop at ETH for All. And yeah, we are going to get started with the hackathon day after tomorrow. We are going to do the kickoff in person, but the reason we also kept a couple of workshops before the hackathon kicks off is so that you can sort of get the ball rolling. You can get some idea on what you want to build or how to get started with Ethereum if you're new to the space. So yeah, and with that, without any further delay, I would like to introduce the man, the myth, the legend, Austin Griffith, who has been, it is not an ETH India online workshop if Austin isn't a part of it. He has been helping us with the 101 since, I think, like for me, and I know since 2021. So a lot of fun. And yeah, he is like one of the OG builders in the ecosystem. Not only he's contributing, but he's also helping others get onboarded, get started with building on Ethereum. Lots of quality Kickstarters are there as well. There is Scaffold ETH. We're going to also be talking about a little bit of speedrun Ethereum. So yeah, thanks Austin for making out the time and joining us over here. Over to you.
Yo, thanks for having me. Happy Thursday. Is it Thursday? Yeah. Thursday night for you guys, right?
Happy bow tie Friday.
Yeah, it's not quite Friday. It's not quite today. Yeah. How do I get to the Q&A? I see the Q&A here, but if there's Q&A and there's good questions, shoot them my way and we can kind of just answer them in line. I thought I was showing off speedrun Ethereum, but I think what would be better if you guys are just getting ready to start a hackathon would be to show Scaffold ETH and just kind of talk about hackathon tinkering and creating projects for hackathons. But also just interrupt me with QA questions. For some reason, I can't see them. Sure, I don't know if I need to do some.
I'm going to be helping you out.
You got it?
Yeah.
Awesome.
So folks, if you have any questions, feel free to put that. You can see a Q&A section below on your Zoom. So feel free to drop in questions.
Oh, wait, I found it. It was a different window. Okay, yeah. Got it. Okay. Yep, I see it. Cool. Yeah. So shoot your questions there and I can answer them. I don't know what the prizes are for ETH for All for the hackathon, but I can tell you how to get started working on and building a hackathon project and starting to think about what are good hackathon projects. So if it's cool, can I just share my screen and we can start tinkering away? Does that sound good?
Yep.
Awesome. Okay. And we're going for probably like 20 minutes or 30 minutes and then questions or something along those lines?
We can do 30
awesome.
minutes.
Okay, cool. Awesome. Okay, so originally I was going to show off speedrun Ethereum, and speedrun Ethereum is a great way for you to get context for what kind of things you can build on Ethereum and what kind of things work and what kind of things don't, sort of. In particular, there's this decentralized staking app. It teaches you about kind of how you can build a set of rules for an adversarial group of players, and they can coordinate financially using your smart contract, and they only have to trust the code of your smart contract. And that's kind of like a key insight when you're building on Ethereum, is there's this kind of trustlessness where you have lots of people and they don't trust each other, but they want to interact with each other. They want to coordinate. So you have these smart contracts that have rules written in a certain way that doesn't allow people to get griefed, basically, right? In this decentralized staking example, if I were to stake and then someone else were to be able to steal my stake, then it wouldn't be a very good staking app. You need a staking app where people stake, and if you're able to get everybody to coordinate, then it works out and it moves on to the next round. But if they don't coordinate, they need to be able to get their money back. They need to not have it locked in it or have it stolen or something like that. And writing those rules and writing that smart contract correctly is kind of what this is all about and what we're doing here. You'll move on and you'll do a token vendor, and you'll learn things like the ERC20 standard and how to make smart contracts more like vending machines, sort of. And then the dice game talks about randomness. It starts to get a little bit more wild. And there's also an opening for BuidlGuidl, and I can talk about the BuidlGuidl a little bit, but I think what we want to do is we want to roll it all the way back to Scaffold ETH, and we want to talk about how to get started quickly building apps on Ethereum and how to get started kind of tinkering. And that's kind of what I'll show off here. Let's see, maybe make this a little bit bigger. Awesome. Okay. Watching the chat here. It's okay if you're a total beginner too. I'm going to kind of just do this from a high level. If you're a good builder and you've gotten started already, that's great. If not, I'm just going to kind of talk through it pretty slowly here. So Scaffold ETH is a package that includes Hardhat, React, and a few other handy scripts that have helped us kind of create hackathon projects in the past. And you can just clone it down. It's just a repo, and I've already done this because it takes quite a bit of time. There's the repo here. You install it. You'll fire up your own local blockchain using Hardhat, and then you'll fire up your React app using Yarn Start. So what you'll have when it starts up is you'll have a blockchain and you'll have your dev server that's kind of hosting your local host stuff. So we'll see that here. Cool. So then we'll move into kind of just like how you tinker with and deploy your smart contract. So with Scaffold ETH comes this kind of default contract. There's a purpose string, and then there's a function that kind of just like lets you set that purpose string. It's very much like the greeter contract of the olden days of Ethereum. But there's also events, and there's this funny little kind of console log here, which is really kind of a handy thing if you're kind of trying to figure out your smart contract and there's some numbers that aren't quite coming up right or something like that. Console log is super handy because you can get an output for what's going on inside of that contract. Okay, so let's just start tinkering around, and let me show you kind of like this development loop you want to get in. So if you go here and you find, this is your app homepage, and you can edit your app homepage in the views home. So this is where that app homepage, I could just like write hello world here and hit save, and we should see that show up here, right? And you'll get into writing your contract and building buttons and all that kind of stuff to interact with your smart contract. But really the place you want to start is over here at this debug contracts tab. So you've got your smart contract here, and then you've got this nice debug contracts view over here. And it lets you basically tinker with your contract, kind of check things out. For instance, if we were to say, let's say an address public owner, let's set up an owner here. And let's set it equal to whoever this dude is here. Okay, and then let's say that, let's require that only the owner can, look at that. That was nice that did that for me. That only the owner can get into this function. And then if we want to test that, it's really simple. We can yarn deploy our smart contracts, and they'll show up over here, and then we can test it. I can say hello world, and we can see if, I need some money from the faucet. See if that works. Okay, that did work. Then we're bringing up an incognito window, and I'm going to go to localhost. And we'll see that it's a different account. Notice I have this kind of like this guy here, and I have this guy here, right? And I even have this one in dark mode or something, don't I? That's kind of cool. Okay, so React Native. Yes, there is a Scaffold ETH. It's called Scaffold Wallet, I think. Sorry, we're just going to go on some tangents here. Someone asked if there was a mobile wallet. We do have a mobile wallet somewhere. Maybe check out the BuidlGuidl. So you would go to just github.com/BuidlGuidl. Let's see if it shows up there. Okay, but back to editing our contract. I'll try to keep an eye on that. But there is let's see, Scaffold Wallet. I think it's this one. Let's see if I can just paste it into the chat. Yeah, there's a React Native wallet. Let's see. How do I paste it? Chat, where is it? Here we go. There we go. Very like forkable mobile wallet that you can get on your phone. I have one running here that's like, let's see. There it is. Oh, I love this thing. Scaffold Wallet loading up. Oh, it needs my face. Yeah, okay. Anyways, yes, there's even a mobile wallet built around Scaffold ETH with the goal of making a very forkable example that anybody can clone and build on. Okay, so let's go back to smart contract tinkering. You're just getting started. You bring scaffold ETH down, you get it installed, and you want to get in this loop where you can make some small changes to your Solidity and then go to your front end and test it. Okay, we added this owner guy, right? And that's this guy here, and that shows up here. If I add some, let's see, we've got a purpose that shows up there. I can add any variable here, right? So let's add a U256 public counter. And let's not even initialize it, but what's going to happen? If we deploy that, we're going to get a counter over here and it's going to be 0 already, right? Think of it like embedded programming, like microchips, right? We're allocating memory. And if that memory is not set up front, it's just going to be 0, but it's not going to be like null or undefined or anything. It's 0, right? And then if we wanted to, maybe every time someone sets the purpose, we could do something like counter plus plus, right? We're just kind of adding these little things in. Let's see, let's take out the owner thing too. No need to just make it so only one person can, whoops, I just closed it. Let's see, what did I do here? This thing. Let's take out the owner for a second. Okay, so this time instead we've changed our smart contract. So there's some string purpose. There's a function that lets us update that purpose. Anyone can call that function, and when they do, we're going to increment a counter for some reason. Okay, and let's just go ahead and yarn deploy it. This is kind of the loop you want to get in. You want to just be making small changes to your contract, and then doing a yarn deploy. You can even do a yarn watch over here, and it will just watch for changes of your contract and deploy them. Sometimes that gets annoying and weird, so it's kind of like up to you, the builder, how you want to do it. But let's see what our new contract looks like, right? We should see it show up over here. I kind of want to shrink this a little bit. There we go. Maybe scoot this over. I'm going to do another deployment. I'm going to do -- reset. That's going to like force a new contract right here. See that address change? Let's keep doing that. There we go. So you want to get in this kind of pattern of I'm making small changes to my smart contract. I'm testing my intuition. Then I deploy it and show over here, and I just like make sure it works like I think it does. For instance, I should be able to say hello world here, and we should see this counter go up. There it is. Nice. And this should be 2, right? All right. So now let's see if I hit save there. There, it goes to 2. Okay, there we go. So we've created a smart contract, and the app just kind of comes along with it. We could ship this app right now if we wanted to. We need to deploy the smart contract to a public network and everything. But this is like really like your tinkering zone where you can kind of try things out, but it's also like a launch pad where you can, deploy this thing if it works out and it does what you want it to do. So let's see. Let me double check the chat real quick to see. Yes. Okay, so someone pointed out I'm making a change in the smart contract and we're seeing that show up over here, right? So to show that a little bit more, let me just grab my account. Let's say we wanted to make address public Austin, right? This is going to be me, right? And I'm going to save that. You'll notice I just added a new address to my smart contract and I deploy it. And then you'll notice it shows up over here, right? And the question is, how is that happening? Basically, your contract is compiled and it creates an ABI. And with these artifacts, we can inject those into React and build a form that tells us kind of what are the different methods we can call on your smart contract. And then we can start getting those values and creating a form here where you can mess with it. So that should answer that question. Basically, that's how Scaffold ETH is built, and it uses the ABI and artifacts from Hardhat to create this experience where you can kind of just make some small changes, hit deploy, and then tinker with it over here to make sure it works. Okay, so let's see, just checking. Okay, ideas for projects, that's very, very hard. I mean, like, it's hard to come up with a really, really good hackathon project idea, but it's not hard to come up with a project that you need to build anyway. And let me like lean in on that a little bit. So as you get started with building on Ethereum, you kind of go up the Dunning-Kruger graph where you understand a little bit of Solidity and you start tinkering and you're like, oh my gosh, I could build anything in the world. There's definitely a time where you need to build a bunch of little things to understand all the stuff that you don't know. There's so much you don't know when you get started and you think you know it, and you just need to build a bunch of things. And by building a bunch of things, it's going to open that knowledge up to you. So I have this idea of this tech tree. I think it's a good time to jump to this for a second so we can talk through this. So first of all, speedrun Ethereum. You should go to speedrun Ethereum, and you should go through these initial challenges, because they're going to force you to write some Solidity. They're not going to hold your hand, but they're going to help you kind of really get the idea down of like what we're doing here and what we can build. But then it kind of opens up, and you need to build a bunch of things. You need to just like try a bunch of things to understand all the different parts of the ecosystem. So one of the first things that I tell developers is to kind of put away this front end for a little bit. Even though I love the front end, I love building apps, I love building things that people use. Build your own just command line interface. Just build your own CLI. Just a simple little script that uses ethers.js that lets you query values from a smart contract, write values back to a smart contract, listen to events from a smart contract, something along those lines. You can go down a rabbit hole where you have like burner wallets and Etherscan API and all these other APIs integrated, and you're reading from the mempool and you're using ethers in a deep, like cool way. You can get to that, but start by just building your own scripts and having your own set of scripts laying around. And to lean into this, of course, other people have done this, but do it for you. So A, you have the knowledge and you kind of cover these kind of gaps, but B, you also build yourself a set of scripts that you can use, right? Then it's kind of like down the waterhole of different things that you can build. The dice challenge is a good one on speedrun Ethereum. Building just wrapped ETH, so you understand how ERC20 tokens work. Building some kind of challenge around timing and incentives. This is kind of what the staking challenge is, but just understanding that you can kind of program your smart contract based on different timestamps or blocks, and then have some event that needs to happen by that time, and then have some incentives for folks to do that event, and kind of building that kind of app. You'll learn more here at the decentralized staking app than probably anything, but once your world opens up there, you can kind of come up with your own incentive built challenges, right? Okay. Building a smart contract wallet. So build a smart contract that holds money, and then you can do all sorts of things like social recovery, being able to send that wallet around, right? Account abstraction is a big thing in Ethereum right now, and finding a way to kind of make Ethereum good enough for mainstream audiences has been something that's been really challenging for builders. It starts with building your own smart contract wallet and learning call data and how to call on things, and then kind of how to extend that wallet to make it more friendly for users. Build a token wallet, right? If you build a token wrapper, build a token wallet. Build a little wallet on your phone on Goerli or Sepolia, and deploy it so your friends can all send around your token, right? That's a lot of fun, and it will teach you so much stuff about like what we're building and all the little gotchas that happen. Eventually in the speedrun is the exchange, right? Learn how to build your own like V2 of Uniswap, where you have reserves and people can swap between those reserves, and you're earning fees. And not just you are earning fees, but any LP. It's a hyperstructure that any LP can participate in. They can bring in their funds and they can earn money on their funds by having them swapped around in your smart contract. And you can't steal their money, right? It's like built so no one can grief each other. It's a really beautiful contract. But yeah, get into the decentralized, there's a whole challenge here down here at the bottom for building your own DEX. And it's just something you should do to go through. But then it really kind of opens up, like learn price feeds, learn oracles, learn NFTs on a curve, build an app that uses NFT gating, kind of along the lines of these like simple token builds. Build a little token multi-sender. I know it's simple, but you can get in here and write some, like this set purpose function could send $10 to Austin and $5 to someone else. And that's a cool token splitter. But by building that, you'll learn a lot about how this stuff works. Signing and recovering is big. You can sign a message and then verify it using ECDSA key pairs, but also you can sign a message and you can EC recover it inside of a smart contract. So a smart contract can do signature-based stuff. So for instance, a bunch of my friends could sign messages, and then I could pay the gas to put one transaction on chain. and it could parse through all of those signatures and prove cryptographically on chain that all my friends had signed those messages. Maybe they're, sending tokens around or something like that. The multi-sig challenge is kind of an extension of that. Once you understand signatures, you should understand how to build a multi-sig. And the multi-sig really pairs nicely with this whole smart contract wallet thing. And you'll get to that eventually. If you go down and build your own CLI and you really like it, you should run your own node. I have my execution and consensus layers running here. This is Prism running here and Nethermind over here. Run your own node. It's so cool to have your scripts be able to query your own node for things. It's so fast and awesome. But also, yeah, this guy's like making a little money too. Not much, but a little bit. Then it starts to get a little deeper, right? Learn ZK stuff. Take on that Circom starter kit. Learn how decentralized lending works. You'll use like a price feed and similar logic from your exchange. A prediction market, right? Why don't we see more prediction markets? We should see some more prediction markets built on Ethereum. Build a Merkle NFT. So an NFT that can be minted by a huge list of people, and you could put them in this Merkle tree, but then they have to claim it and they have to prove that they exist on this tree, but it works in a pretty gas efficient way where you can have lots of addresses get a mint, and that logic happens on chain. But it's but let me just let me share a public link for this, and that will get people deeper. You can kind of explore this. Token curated registries are really interesting. If you're starting to get into multi-sigs and how smart contract wallets work, how DAOs work, right? You should learn, just like build a simple proposal system so people can vote on proposals on chain, and that'll teach you arrays and structs in Solidity, but also learn how the Moloch rage quit kind of changed, it changed willingness to participate in DAOs, because you could participate and know that you could eject and get your capital. And I think that kind of changed participation. And the Moloch was one of the very first DAOs out there. So just getting the history of Ethereum is also kind of a rich thing there. Front run an NFT, get into the mempool and learn how the mempool works. Take your scripts that you built here and build a front runner that goes and front runs some NFT. Like my favorite is the Prometheans. This is This is a really fun NFT project that will probably never die. I bet people will continue to mint this forever, but if no one mints for 15 minutes, then they go away. But what you could do is you can watch the mempool and you can get out ahead of someone trying to mint theirs, and you can get a fancy one. So go front run the Prometheans. That's a fun one. Then deeper into the Circom stuff, learn about Compound's governor system. Like I said, a simple proposal system. Start learning about L2s and bridges and state channels. DEX sandwich attack, that's kind of an extension of the DEX. MEV, right? You start to get into what's happening with MEV and how you can bundle up transactions that never even hit the mempool using Flashbots. So lots of fun stuff here. And then, you're leading to get good at auditing. If you're a particularly good Solidity developer, you should probably learn Winter's EVM from scratch and then start moving into how to become an auditor. Take on the Ethernaut first if you're wondering if you've got the stuff for it. And then, on the other side of this, the ZK space is so exciting right now. Like the combination of smart contracts and ZK, it looks like, I don't know. There's so much stuff we can build there. So hopefully that was like a huge spew of like random things that you should build. Maybe not particularly for a hackathon, but you should build them for yourself. Go through this list and build these things just to get better at building, and also like finding all the blind spots. There's so many blind spots within your knowledge. Let's see. Let me go through this. Okay, changing the contract shouldn't change the ABI every time. Yes, it does. I mean, when I add something here, it's going to change the ABI. The ABI has all these different functions. So by making any change here, the ABI will change. But if I don't change anything, the ABI won't change. But yeah, this is just a reflection of the ABI. As I make a change here, compile it, the ABI changes, then that's injected here. Okay, contributing to open source. Of course, you should definitely contribute to open source. Go find repos that are Ethereum aligned and get in there and find issues. Scaffold ETH probably has some. Scaffold ETH probably isn't a great example. It's probably messy. We've got a lot of issues from folks and a lot of pull requests that are unkempt. But find things like client projects, right? Like Nethermind is a good example, like Nethermind, Prism, all of these client projects. There's so many really, really, really smart people that are just like thanklessly building these awesome things. Go help them. Go get into their repo and look for PRs. And not just at the client layer, but probably higher up at like the application layer first, right? Go look at open source Ethereum applications, go look at their issues and just start contributing there. I'm going to paste this Miro board in here. Okay, yep, Miro link. Everyone's like Miro link. Okay, Miro link is there. So by the way, if you zoom way out, there's like 3 different versions of the tech tree that I tried to go through. And so there's lots of stuff to explore in here, but it's this Charlie, it's a crazy fever dream. So it's pretty weird. So then I tried to kind of isolate it down to just this small tree. And this is a little bit easier to follow. But yeah, sorry about the mess of the Miro board, but it's there and please go explore it. Another thing is scaffold ETH examples. So scaffold ETH examples is this huge, like say you're building an NFT, just come here and search for it. Say you want a bonding curve, right? Say you want a, I don't even know, SVG NFT. Yeah, there we go. There's so many things in this repo. I'm gonna paste this here. It's right there. That is the scaffold ETH examples. So that's a separate repo from scaffold ETH. Scaffold ETH, you can go to, let's see, repositories here. Ooh, I should mention, look at this, SE2 is happening. So there's a new version of Scaffold ETH and it's probably about ready to start building on, but it doesn't have the track record of old Scaffold ETH. So if you're interested in exploring, this is a little bit better stack. It uses Next.js and TypeScript, and it's a little tighter. So if you're interested in that, Scaffold ETH 2 is here. I'm going to paste that into the chat. All right, someone just asked about an NFT marketplace, right? Like that's so hot right now. So many people are figuring out how to make things like SudoSwap is so cool. If you haven't seen SudoSwap, go check out how SudoSwap works. Go look at their GitHub and help them out. Okay, but here's Scaffold ETH here. But maybe there is a project, let's see, maybe there is a project in Scaffold ETH examples that might help you with the marketplace. We were talking about a marketplace earlier, right? So if I go to the Scaffold ETH examples and I look for marketplace, is there one? Ooh, backlog.market. Oh yeah, I remember this. This is a long time ago. Okay, so this is just like a bonding curve market on GitHub backlog issues. Something that like someone should build, and I don't know if anybody has built it yet, but imagine if there was a market for like the MetaMask issues in their GitHub, right? Yeah, there we go. Imagine if like, yeah, in here, each one of these had like an amount of money and people were able to like bet or invest into certain things. Both of those sound like scary words in terms of regulation, but that's a whole nother angle that I'm not even going to talk about here. Is there's probably less people tinkering on Ethereum because of like regulation rather than tools or anything. All the tools are here. Everything is here for you to learn. People are just afraid because of regulation, which is sad. Okay, I think I've almost covered like a lot of different links to get you guys started. Hopefully this is clear how you can go about kind of making a little app. I'm gonna go, let me, I think I deleted the Q&A. Okay, let me just make something real quick. We got maybe like 10 minutes. Maybe I can just like build something or, oh.
Yep.
Speedrun link. So it's just speedrun Ethereum.
Yep, I'll paste it.
Cool, speedrunethereum.com. Yep, that's this one, speedrun Ethereum. Okay, let's do I have 5 more minutes or something to keep tinkering? Because I can show a little bit of just like how to go from tinkering to, okay, this is becoming a little bit more of an idea, but we might be close for time too. How are we doing on time?
Yeah, I think we can like do a quick
okay, cool. So there's this payable right here, which is really interesting. It's not even being used. I don't know why it's in master branch, but if I go ahead and remove that payable and hit save and go ahead and deploy that, we're going to see this thing disappear, this little box right here. There it goes. So now it's gone. So now this function is free, right? Hello world. You still pay gas, but you don't have to pay anything to the smart contract. So by adding this payable, what we're saying is someone could send money into this function. So that means that we could require, instead of requiring message.sender, this is very like centralized, right? A single person can get in and call this function. What you want is to have anyone be able to call the function, but have them correctly incentivized and have the rules written correctly. So let's do something like they need to send in, so message.value is the amount of money that comes in when they do this. They need to send in maybe like 0.01 ether or something like that. And then we'll say not enough. So we've made this a little different. We've made it so you can update this purpose, hello, but if you don't send in any money, it's going to say not enough. So we need to probably get some money from the faucet here. There we go. Now we have more money than we need. But if I say 0.01, okay, first weird lesson of having to build with Ethereum. And this is why you want to build all these things to teach you all these blind spots. Here's a blind spot. What the heck is going on? If I try to submit this, it's going to say invalid argument. It doesn't like this decimal value. So this decimal value, smart contracts don't F around with floating points. They can't do decimals. So what you need to do is multiply it by 10 to the 18. Okay. See this? That's super weird, right? Well, what that is the difference between ETH and WEI. So we have Ether, so we can use decimals, but really this number is the exact same thing as this right here. So these two things are exactly the same, okay? But for humans, we want to read this nice little decimal, but the machines, they need whole numbers, and that's why we do this kind of like we'll shift it by 18 decimal points, so then we can have fake decimals, right? And so that's the first thing, first weird thing of Ethereum you have to learn. You have to take things two-way on the way in. So we have hello, and we're going to pay 0.01 ether, which is this many WEI, and we hit send. And sure enough, we pay a little bit of money. And look at this, money goes into the contract. That's kind of a cool thing because the contract itself now holds value, right? The contract itself is an address that has, wow, it even has value on mainnet. Go talk to this dude about deploying that. should not have sent money to that on mainnet. Okay, let's see. So we've created a function that says you can pay once, okay? Now, all the time, whenever I'm looking for, here we go. This is a huge tip that I probably should have said earlier. Whenever I'm looking for inspiration, or I'm looking to find a little bit more about Solidity, or try to just like, maybe I need to learn how to send Ether, and there's like send and transfer and call, and I want to remember which one I want to use. You should always use call, I think. But I go to Solidity by example. This is a huge alpha leak. Solidity by example. Just Google Solidity by example and find this right here. This is a huge alpha leak for anybody who is trying to learn Solidity. There's so many great examples here. Then there's also applications. There's even hacks, and you can get in and kind of replay these hacks. There's even like, DeFi and Uniswap and liquidity and all this other stuff. But just to get started, let's go over here. I don't even know, what was I going to do? I was going to grab, I don't know what I was going to do, but this is, I use this all the time. So let's see, let's go grab, we were talking about arrays and structs earlier, right? If you want to learn an array, you can just grab that thing and just paste it in here, right? Hit save and deploy it. Let's see if it deploys. Let's see how our contract changes. Yes, now there's this array, right? And if I ask for element 0, I get that. If I ask for element 1, I get that. Element 2, I get that, right? So it's working, right? And so what you want to do as you need inspiration, as you need more Solidity guidance, you can come to Solidity by example, and you can grab whichever thing, like let's make a mapping, right? Let's grab this mapping and let's paste it in. And it's a mapping from any given address has some number. I'm going to do uint 256 just to be explicit there. So any given address has a number. What's that? Well, that's kind of like a balance, right? And let's just go ahead and when we deploy our contract, let's give this character of mine here, this address, a balance of 100, right? Not even 100 ether, 100 WEI, right? So he has a balance of 100 WEI. And then each time someone pays into this, the balance of this guy, I have no idea why I'm doing this, but goes up 1 plus plus. Okay, cool. So then if we deploy this, we should get our app over here. And then if I were to ask for the balance of this guy, right, it's going to be 100. And then if I say hello world and I pay my 0.01, there it goes. And then if I check for the balance of this guy again, it should be 101, right? For some reason, right? Where I don't know why I'm building this, but we're just building this to like as an example. So let's say, let's do something else. Let's do something else. Let's say this price right here, right? We have this kind of price variable. This is interesting. So let's do a UNT 256 price, and we'll start it out at this. All right. And we'll make sure you pay the price. Okay. But then let's do something tricky. Let's say price equals price times 102 divided by 100. What we're doing there is we're creating a percentage, right? We want the price to go up by 2%. You might even want to do it like this to be very explicit about your math. And then let's deploy it. Oh no, what's this balance? We don't need this anymore. So now there's a price, right? And we have to pay the price. Ooh, this is a great little screw up that helps out. Notice I didn't make my price public. Over here, it didn't show up. I put a price in and it didn't show up. What the heck? I'd want to get like really mad at this, but look, this needs to be public right here. There we go. And as soon as that variable is marked as public, then it's going to show up over here. And remember, you're using a public blockchain, so everything is technically public. This has to do with like view access stuff, but you can always get to all this information. Nothing is private on a public blockchain unless it's like hidden behind ZK stuff, right? Okay, now we have a price we have to pay. And if we pay this price and we say hello world to our little, it's kind of like this little a machine that we're talking to, right? It's kind of like a little vending machine that we're talking to, and we're going to pay that money. Now look what happened. The price went up. If I try to pay the same amount again, it's going to say not enough. Now I need to pay this price. Oh, right. And watch the price again. Oh yeah, got to take it to way. Watch the price again. It's going to go up again, right? So what we did is we made a machine that lets people post a purpose, maybe some attestation, but each time they do it, the price gets a little bit more and more expensive. And what we could do is we see that this contract is now starting to accrue value, right? We'd want to build some other system that somehow uses this money. Maybe it lets people sell it back or something like that. Hello, number 3, we can see how this contract is slowly getting more and more money in it. You'd have to build some kind of system, do some mechanism design to get people to do something, right? So hopefully this kind of like opens up your world for tinkering. Go grab scaffold ETH, get this set up where I did a yarn install and a yarn start, a yarn chain, a yarn deploy. Get into this mode where I can grab something from Solidity by example, paste it into my contract, deploy it, and tinker with it with scaffold ETH. And then when you like this, you could do a yarn build, and this will build it to a static website, and you could yarn Surge or yarn S3 or yarn, wherever you want to put that static site, you can basically deploy this site up. I don't know what Motco is. I don't know. Solidity, in terms of languages, Solidity and Viper are the 2 languages. I don't know what that other one is. Our ETH price is good for the ecosystem. Our low ETH price is good. Yeah, I think this is like an overall kind of game theory question, right? Like the price of Ether like secures because my validator is running over here and it gets paid to secure the network. So having value to the network makes it more secure. But I think that like low gas prices are good because it's better for users and they're able to make a transaction and it doesn't cost a lot. So yes, I think that low gas prices are good for like mainstream adoption and things like that, but also like this price that we're paying is for a reason and it keeps the network secure, and that's like headier stuff than I'm going through here. But Yeah, I think low gas prices are good in a way. I haven't tried FE Lang. Okay, shoot those questions in if you have more questions or anything I need to post or any links. Yes, you can use ++ in Solidity. You do want to, there's kind of a lot of gotchas that you want to pay attention to. Like for instance, if I have a uint 8, right? And we start that at, we'll just call this something, and I put this at like 200, right? And then I have a function increment that's public, that's going to take that something ++, right? Now watch what happens here when this gets deployed, right? Like your question of can you do that? You should just go get scaffold ETH and try it, right? There's one good way to find out if you can do that. So our counter is down here, it's at 200. And every time I hit increment, we see our counter going up. Oh man, I don't want to hit it 250 times though. Let me do this.
Austin, I'm sorry, but
Yep.
I think you had stopped sharing your screen.
Okay. Oh, I did stop sharing my screen. Darn it. Shoot. Let me put that up there. Hold on. Sorry about that. Okay. So I have a variable called something that's a uint 8, and it's displayed here. And then I have another button that lets me increment that. I typed all that stuff without my screen shared. But basically, I created a variable something. This price doesn't matter. I can put that somewhere else. It's just this loop that we're looking at right here. So this is a uint 8. There's only 8 bits used to track this number. So it can only go to 255. And we're going to increment it into 255 and see what happens. Okay, so we're at 250. And we do increment 251, 252, 253, 254, 255. It's okay. But if I hit 256, look at this. I get an arithmetic overflow and it fails. So it doesn't let me overflow that value. Now, if I do something like unchecked, sorry, we're running a little bit longer, but this is kind of some fun stuff to play around with and help you kind of get going on your Solidity journey. Now watch what happens. It's at 250, 251, 252, 253, 254. Where's it going to go? Anybody have any guesses on where my next increment is going to go? Here we go. It's going to 0. It rolls around, right? Because of those bits, right? And they were all set high. We added one more to it, rolled around. Another fun thing to play around with Ethereum and to watch out for. Yeah, I mean, like, so there's this really weird thing where, so someone has asked, do they hire new grads for Solidity dev roles? Definitely like junior roles, right? There is this idea that, only 10 people in the world can write the best smart contracts. And in terms of things like Seaport, that was written like in assembly, basically by that one dude, like that is like on another level, right? When you are building a smart contract that thousands of people are going to use, and that as soon as you deploy it, thousands of people are going to use it, and it's like wild, you need that thing to be very, very efficient. But if you're tinkering with new mechanisms and trying new things, just like we did today, I could have written out a small app that lets people pay money and the price goes up and they can make an attestation, and I could deploy that to mainnet and kind of be slightly confident that it's not going to lose all its money. You should be very careful about that. You should audit things. You shouldn't put smart contracts on mainnet without auditing it. But the point I'm trying to make here is that tinkerers are still very valuable for Ethereum. Even though there is like this level of like godly, Solidity developers out there, and there are like, a handful of really, really good ones, and only they should write like these specific like OpenSea contracts. There's also a long tail of hundreds to thousands of different apps that are getting deployed on Ethereum. And if we're all counting on 10 guys to write their smart contracts, they'd be in a lot of trouble, right? So it's definitely open for anyone. You should learn Solidity. You should learn how to tinker. You could be just building your own little app or your own little NFT. You don't have to be building something that like thousands of people are going to use. It could just be an escrow contract between you and one other person, and you just happen to know how to write Solidity, and you just make the escrow contract real quick, and you two can trade something, and it's just a valuable asset for you, right? Let's see what else we have. Unchecked syntax. Yes, before like Solidity 8, there used to be safe math, but before that, yeah, you would use unchecked math and it could roll over, and that was an attack. Blockchain security is absolutely a good field to get into. That's like one of the hottest fields. And the best way to do it is like learn Solidity, learn the EVM, and then go start participating at places like Code Arena.
Cool. I think if we can take one more question, if anyone has any.
Go speedrun Ethereum. I think that's a good, if you have a couple days before the hackathon starts, pull down Scaffold ETH, learn how to tinker with Solidity, go do the first couple challenges of speedrun Ethereum, and they actually have you ship an app. Like after the first challenge, you put something out on a test net and you can share it with your friends. So it goes from 0 to 1 right away. So go speedrun Ethereum before the hackathon and you'll really be prepared to ship something. Good EVM. Okay, so low-level EVM resources is Winter's Solidity. Ooh, it's in the Miro board. If you go to the Miro board, I'll just go get the link. I'll go get the link. After the Ethernaut. So go do the Ethernaut first, but then it's called EVM from scratch. And let me paste that here. Oh man, I don't want the Miro link. Come on, man. Just a second, let me get it. EVMfromscratch.com is what it is. Yeah. This is a course from Winter, and it's a really good course. So it's just EVMfromscratch.com. Okay, let's see.
Cool.
Yeah, low-level EVM. Someone's asking how Scaffold ETH loads the contract functions. It's from the ABI. The ABI is compiled in, or the artifacts come out of Hardhat, and we inject those artifacts into the front end. Yep. And inside the UI, I think that was to that same question. Yeah. Oh, yeah. All of those questions are the same. It's compiling the contract. An ABI is created, and then that ABI is injected into the React, and so then it knows what functions it can call on the contract.
Cool. All right. I think we are done. Thank you so much, Austin, for taking out the time. I think even I got to learn quite a few things on that. And yeah, like thanks everyone for putting in the questions as well. I think this was definitely helpful and a great Kickstarter, even for like the hackathon. So yeah. And those of you who are here, we'll also be starting with the next workshop right now. So we hope to see you there, and we have sent all the links and everything.
Sorry, I ran over time. I didn't know there was another workshop
worries
coming
at all.
up.
Always great.
Sorry to the next presenter. Ooh,
No.
nice. Someone just pasted like a wall of links. Thank you for that, PK. I like that. All right. Thank you all. You can reach out to me on Twitter too. I'm at Austin Griffith on Twitter, and my DMs are open. Let me grab that real quick just so you have it. There we go. All right. Thank you. Thanks for having me. Good luck on your hackathon.
All right. Thank you, everyone.
All right. See you guys.
Bye-bye.